Welcome back, you guys. Let's get going on example 2. So this time we're finding the geometric mean of 2 and 20. And don't forget, we use this nifty formula to find our geometric mean, which if you understood example 1 and you'd like to try example 2 on your own, I say go for it. Try it on your own, then fast forward to the end and see if you got it right. Otherwise, let's get going. Example 2, I'm going to use this formula. So I'm going to find the geometric mean of 2 and 20. So I'm going to make the 2 the A in my formula, and I'm going to make the 20 the B in my formula. Okay, and I just fill everything into this nifty formula. Remember, you leave the x's as x. Don't touch the x. Okay, let's get going, you guys. So in my formula, the x's are going to remain as x. Actually, I used the wrong color. Oh no, I like to color coordinate. And then the A and the B, I'm just going to fill in. So the A goes in the numerator over here, and the B goes in the denominator, which is 20. And guess what, you guys? Since I have a proportion, I'm going to cross multiply. So let's do it. Cross multiply. So x times x will give me an x squared, and that will equal the other way. So now I'm going to cross multiply the other direction. Okay, so that will be the 2 times 20, which 2 times 20 gives me 40. All right, now how do we undo a squared? What's the opposite of a squared? It would be a square root. So I'm going to square root both sides. Square root that thing. Okay, which the square root will cancel out the squared, and I'm left with x equals, now don't forget, technically, okay, when we square root both sides of an equation, what will appear in your equation? What appears in our equation when we square root both sides? Technically, a plus or minus will appear, but in geometry, having a negative average does not make sense. So in my final answer, I'm not going to include the negative. So we have plus or minus the square root of 40. And is 40 a perfect square? Oh no, it's not. Okay, but what do we do when we don't have a perfect square? We're going to do a factor tree. Okay, so I'm going to break it on down over here. Going to break it on down. Okay, so two numbers that go into 40. Well, I definitely know 2 times 20 does, because that's what gave me 40. So 2 times 20. Okay, and 20 will break down into 2 times 10. And 10 will break down into 2 and 5. Okay, now remember, you guys, any number that has branches coming off of it or that breaks down, we ignore. I'm going to ignore the 40. I'm going to ignore the 20. And I'm going to ignore the 10. I'm only looking at the numbers at the ends of my branches or my leaves. Okay, so for my final answer, let's see what will happen. Okay, do you guys spot any pairs at the ends of the branches? Do you guys see any cute couples that get to go on their math date? I see them. Do you guys see the lovely pair of twos? Okay, which you can pick any pair of twos. You can pick these two twos, these pair of twos. You could pick these two. Okay, whatever you want to do. I'm just going to pick these two because they're right next to each other and they're easy to draw. Okay, and oh no, I don't have any other pairs. Okay, so my pair of twos, remember, for each pair you circle, only one will hop outside your square root. And the two numbers that don't have a pair, my sad, lonely numbers, so my 2 and my 5, they will remain inside the house for the night. They don't get on their math date. Okay, so the 2 and the 5 stay in for the night. They stay inside my square root. And whenever you have more than a number, either outside or inside your square root, you always multiply them together. So I'm going to multiply the 2 times the 5. Okay, so for my final answer, I'm going to get x equals 2 root 2 times 5 is 10. And guess what, you guys? This problem is officially donezo.